Welcome to Train Signal. You're watching a video about troubleshooting. We're going to break this video into two main components. We're going to start off by talking about the overall process of troubleshooting. And then after we look at the process of troubleshooting, we'll go in and take a look at some of the common connectivity issues that we can run into in our networks. So first, let's talk about the process of troubleshooting. Now, before we get into this at all, I want to tell you that when it comes to troubleshooting, there's no one magical thing that I'm going to tell you right here, right now, that's going to make you the absolute foremost troubleshooting expert. Basically, troubleshooting is a process, and I'm not talking about the process here, but it's an overall process of, first of all, having an understanding of how things work. So really, I've been teaching you how to troubleshoot from the very first video in this course. So the first step has to do with just knowing how things work. Then you take that, and when you are presented with a problem, well, you need to kind of go through the process as it's supposed to work and then figure out where things are not working correctly. And there you have troubleshooting. Now, to be a little more specific, I have a list for you here where we start off by gathering information. Okay, that's the very first step. If somebody says there's a problem, start gathering information. And where do you get this information from? Well, anywhere and everywhere you can. In other words, the first place probably would be, well, the user, right? The user who's complaining about the problem. From there, you might be able to gather additional information from different monitoring utilities you may have running, different logs you might be able to go look at. So you want to begin gathering just general information about the problem. And you'll see that some of the other bullet points that we're about to go through here include some of this information gathering. But you just want to just start gathering information. The more you can know about a situation, the better your chances are at solving that situation. You could almost kind of think of it like a police detective. When they're trying to solve a crime, what's the first thing they do? Well, they go to the crime scene and they start gathering information, start gathering evidence, as it would be. They go out and start questioning people. They gather as much information as possible, and the more information they have available to them, the easier they can solve the crime. So it's kind of the same thing here when it comes to troubleshooting network problems. Now, the next thing I have listed here is who's affected, or we even could say who or what is affected. In other words, if somebody calls you and says, I can't access the file server. All right, well, is it just that person that can't access the file server? Or are there other users that cannot access the file server? Can the file server communicate back with this user or with other users? If there is more than one user that's affected, is it everybody or is it only a certain section of people? And if it's only a certain section of people, well, what do all those people have in common? Do they all sit in a similar physical area? Do they all belong to the same group? So you really need to break it down to not just what is the problem, but where or who is affected by this problem, or what is affected by this problem. The next question you need to ask is, what's changed? And that's a really, really important question, because in general, things don't just happen for no particular reason. In general, when things go bad, if you have a good functioning network, if something isn't working, it's not working because something has changed and you no longer have a good, well put together functioning network. So what has changed? And this is always a difficult one, because here's your typical dialogue. User says such and such isn't working, or I can't contact such and such. Support person then says, well, what were you doing? Or what did you do different? And it's always all about what did you, and then the user, who doesn't have any clue in the world, they just know they can't get to the server they wanted to get to, well, they get all defensive. Hey, I wasn't doing anything. I was just doing my job. So you want to find out what's changed and Again, it can be a little bit of a challenge if you are interacting with a user because they're going to want to be defensive. They're going to think you're attacking them. So try to see if you can find out details without attacking the individual user. But you do want to see what has changed, because very often if you can find something that was done, even if it was just the slightest bit different, well, that slight change could take you right to the problem. This takes us into, well, why is this happening? What is the cause to this problem? See if you can narrow it down to, well, this is happening because of this. Okay? This problem is occurring because the file server is down. There's been a power failure and the backup battery has expired. This is happening because a router is malfunctioning. This is happening because why? Okay, so you want to find the cause behind why you're having a problem. Once you know what's causing the problem, here's a really important question, and I'll tell you what, this question right here really shows who your quality support people are. If you can ask yourself the question, hey, can I handle this problem? Is this something that I can resolve all by myself? And then be able to give an honest answer. That is a quality support person. The problem we run into very often is that everybody always thinks that they can handle any problem. IT professionals tend to be people who want to solve problems. So when a problem is presented to them, boom, they're going to solve it, whether they can or not. And the reason I say that your true quality support person is somebody who recognizes that maybe they can't handle the problem. Maybe the problem is with a router that's in a different office. And although they might be able to remotely troubleshoot that router, they might be able to remotely manage that router, it would be a lot quicker and a lot more efficient to contact somebody in that other office. Or maybe it's a problem that just goes beyond your level of expertise. Well, you're much better off asking somebody else who has the appropriate level of expertise to work on the problem rather than you guessing at it, wasting a lot of time, possibly not solving the problem, and in some cases making the problem worse. So you really want to figure out, hey, can I handle it, or do I need to escalate this problem onto another party? Whether it be escalate up, which is the most sensible form of the word, by escalate, or it could be escalate over. In the case of maybe it's somebody in a different office or a different department, or just maybe an equal peer but somebody with a different level of expertise than your own. So that's something really to take a good look at is can you handle it yourself, and answer it honestly. If you can, great. If you can't and you really are ambitious, then I'll tell you what. You escalate it to whoever can handle it, and then you see if you can work something out to where you participate in the solution. And if you cannot participate in the solution, well, then what you do is you follow up to see what the eventual solution was and learn from it. And that way in the future, maybe you could handle that problem. Now, speaking of solutions, well, that's the next step. If you're not going to escalate it, if it is something that you can handle yourself, find a solution. And I'll tell you what, this process of finding solution is not necessarily a one-time shot. It's not a boom, well, here's the solution and we're done. No, here's the process. It's kind of a three-step process to finding a solution. You find a possible solution, you try it out, see what the results of your solution are, and if that did not solve the problem, or, and there's another really good one, if it creates another problem, because very often you'll find a solution and it solved the problem, it created another problem, but hey, as long as you got the first problem solved, no, that's not your goal. Your goal is to find a total or a complete solution. So you see if it worked, and if it didn't, boom, find another possible solution. Try it out, see what the results are. Didn't work? Try another one. And you keep going through that process until you find a solution, you try it out, and the results are that everything is working great. At that point, you have truly successfully found a solution. And I will also tell you that the process of finding a solution, just to take this a step further, you want to, believe it or not, always try the obvious first. Some people will talk about the KISS method of troubleshooting, and KISS stands for keep it simple. Or since KISS is technically spelled K-I-S-S, a lot of people like to say, keep it simple, stupid. Okay, in other words, again, a real common trait in IT professionals is we tend to be alarmist. We want so badly to have that big problem that we solve. It's almost like a news reporter who really wants to break that big story. Well, there's a lot of IT professionals out there, and you want to be the one that stands out. You want to be the one that said, hey, I solved the big one. We tend to look at small problems and think they're the big one, or turn them into big ones. No, start off with really obvious, simple solutions. Logical solutions. Sensible solutions. And then when they don't work, well, then you start reaching out there for some of the more unrealistic solutions. And yes, sometimes you're going to find solutions and you're going to say to yourself, I have no idea why that worked, but it did. Sometimes the illogical just tends to work, but you don't want to start there. And if we go back to the whole concept of, hey, you want to be the IT professional that stands out in a group, here's how you do it. By following all these processes and doing so in a very consistent and sensible manner. Those are the IT professionals that stand out. The ones that are very consistent and go through bang, bang, bang every single time. Not the ones who find that one massive issue. Never mind that they created dozens of others along the way. Okay? They're not usually the ones that stand out. Or they do stand out, but not in a positive way. Now there's one more bullet point that I have here, and this goes back to a previous video, and that is document everything. Okay, you remember? Talked to you about documentation in the last video, and it's so important. If there's a problem on the network and you gathered your information, you figured out who and what is affected. You saw what changed. You figured out why it's happening. If you could not handle it, if you escalated it, that's okay. I told you, once you've escalated it, doesn't mean you can't follow up with it. After you follow up with it, you can still document. But if you don't escalate it and you work on finding the solution yourself, document it. Document every detail. And by the way, when I say document every detail, you might even want to include the solutions that you tried that didn't work. Some of the best knowledge base articles that I've ever read were knowledge base articles that said, okay, here's a problem. This is what causes the problem. And here is the resolution to the problem. And then along with that are other common resolutions that don't seem to work. What a great way to prevent somebody else or even yourself in the future from trying the wrong thing just because it seems obvious. Okay, yes, I know I just said keep it simple, stupid. I want you to try the obvious, but not if you have something documented that tells you, hey, I know what to do here and it's not that. Okay, so make sure you have really good documentation of the entire troubleshooting process. Alright, so now that we know how to troubleshoot, let's talk about some of our common connectivity issues. And first we're going to take a look at some physical issues related to cabling. Now the first one I have listed here is actually kind of, well, it's listed as a three-part issue. It's crosstalk. Well, earlier when we talked about cabling, talked about twisted pair cabling, And I explained that the reason that we have the pairs of wires twisted is because when you have wires running in parallel with one another, well, what you end up having is a form of signal bleed, where the signal bleeds off of one wire and onto the other, and that is what is called crosstalk. Now, there are two variations of crosstalk, which are near-end crosstalk and far-end crosstalk, which are abbreviated as next and fext. And really, all this has to do with is, well, where is the crosstalk happening? Okay, in other words, with near-end crosstalk, what that means is that the crosstalk is happening, or the interference aspect of the crosstalk is happening near the source of the transmission. Okay, in other words, near the device that is sending the signal onto the cable. Whereas far-end crosstalk is, well, it's the opposite. It's when the interference or the crosstalk is taking place at the far end or near the recipient of the signal. Okay, or a point on the cable that is far away from the original transmission. Okay, so just so you understand, in case you ever see those terms come up, that's what near end versus far end means. Next, we have attenuation. And again, we talked about attenuation when we talked about cabling. And attenuation is the deterioration of a signal over distance. And besides just distance, okay, besides a signal that goes out there and eventually starts to, well, quite frankly, kind of almost just deteriorate, you can also have attenuation issues based upon too many connections. If you have a line of cable and there are a number of devices connected to that line, every connection, well, it's going to take just a little bit away from that signal. It's going to deteriorate it, eat away at it just a little bit. Okay, so attenuation is what makes a signal only capable of traveling a certain distance. So one of the issues that we can run into is possibly one computer, let's say, is not able to communicate with another computer because they are too far apart from one another. And realistically, you're not going to find two computers that are just too far apart from each other. But you can find certain runs of cable that the signal may be trying to use while trying to get from one computer to the other. And those runs of cable might be too long. Now next we have collisions. We previously talked about Ethernet communication as a for instance, right? Where Ethernet is known as CSMACD, or Carrier Sense Multiple Access with Collision Detection. Right? In Ethernet communications, computers will listen to see if there is any other data out on the cables, and if there's not, then they send or they transmit. But believe it or not, two computers may simultaneously believe that the cable is clear and then transmit, and then there's a collision. And when those collisions occur, the transmission stops. Now, a small number of collisions is completely normal. Okay, on an Ethernet network, I mean, the reason we call it collision detection is because we can have some collisions. We will detect those collisions, and we'll try again. And eventually the signal will get there. But if we're having too many collisions, which, by the way, many times these collisions can be detected by you, the human, by looking at your different networking devices, looking at your routers and your switches, because very often they will have an LED, a light that will light up or blink every time there is a collision on that particular line of cable. Well, if you see that light just kind of lit up or blinking like crazy, you're having a lot of collisions. And then when you get people saying, well, how come the network's so slow? Well, you know it's because there's a lot of collisions. Now here we have shorts. No, not the kind you wear on your legs, not the kind you wear in the summer or to the beach or wherever you want to wear your shorts. But we're talking about shorts in a cable. And it's just that. When you have copper cabling, you can have a short, Maybe you have an exposed area of wire and then something else is touching that wire. Or possibly, let's say within a twisted pair cable, maybe some way, somehow, the inside of the cable was damaged to where one of the twisted pairs has had its inside insulation, its inner insulation damaged, and now you have two or more wires touching each other. Well, they are shorting each other out, because as soon as copper wire touches anything else that conducts electricity, well, the signal is going to go in every direction that it can. So it's going to go out all those other things, whatever they may be, that are touching that copper wire. Next here we have something called open impedance mismatch, otherwise known sometimes as echo. And basically, in order to understand this, you have to understand what the term impedance means. And impedance means resistance. Okay, it's resistance to the signal. It's the opposite of the actual signal. It's what's pushing back on the signal. And it's something that is measured in ohms. So if you're familiar with electrical terms, ohms is a measurement of resistance or impedance. Every cable has an impedance rating. If you end up with multiple cables working together and those cables don't have identical impedance ratings, you end up with an impedance mismatch. And what can happen with that mismatch is transmissions can either completely stop, maybe a signal just completely doesn't get through, or sometimes you can have what's almost kind of like a little bit of an echo, because maybe the signal gets divided to where one part gets there faster and another part gets there slower, and it's almost kind of like you're getting an echo. But the bottom line, just to keep this real simple, it just means that you have cables that don't have matching resistance ratings or matching impedance. Thus the name open impedance mismatch. And finally, the last issue we can run into is interference. Now, we already talked a little bit about interference when we talked about crosstalk. But there's another type of interference, and it's called EMI, electromagnetic interference. And basically, we have different things out there that give off a lot of EMI. Some examples would be like a generator. Large generators give off a large quantity of EMI. A real common one is fluorescent lights. We see that in all of our office buildings. Fluorescent lights give off EMI. And basically, this electromagnetic interference is just that. It's interference. If you have a cable that's not shielded against this EMI, and that cable goes near something that gives off EMI, well, then the signal may deteriorate or completely stop. So it's not uncommon at all to see standard unshielded twisted pair cabling running through a drop ceiling, and in that drop ceiling are a bunch of fluorescent lights. That might be a problem. If you seem to be experiencing throughput issues on those cables, well, maybe you need to upgrade to shielded twisted pair cable, because that's what the shielding is there for, is to protect against this interference or against the EMI. Next, we have our logical issues. Now, there's a number of logical issues which pretty much just have to do with the way networking devices have been set up. Right? If they've been set up wrong, then we might have an issue. And right from the top here, we have port speed. And what this means is, yes, on a computer, as a for instance, you have your network interface cards, and those network cards can be configured to function at a certain port speed. So maybe you have a card that is compatible with 10 megabit Ethernet, 100 megabit Ethernet, and gigabit Ethernet. Well, very often those cards can be configured, and you may configure the card to work with gigabit Ethernet speeds. And maybe you have a switch that you're working with which is still only capable of 100 megabit speeds. Well, guess what? Now you have a speed mismatch. You have a speed issue because you have a card that's only going to want to communicate at a gigabit speed, and you have a switch that's only going to communicate at 100 megabit. They're not going to talk. Now, the other issue you can run into here is, what if you have a network interface card that does not support multiple speeds? Maybe it only supports one speed, and that one speed does not match. Same issue. Now, along those same lines, you can have port duplex mismatch. And this has to do with whether the card in your computer, as a for instance, and then of course your other networking devices, whether they can handle full duplexing or not. Can they send and receive at the same time? Maybe they can only half duplex. Okay, there's a number of different duplex capabilities. Well, they have to match. Just like the port speeds have to match, the duplexing has to match. Now, the one thing I'm going to tell you before we go any further, when it comes to speed and duplexing, for the most part, these days, you don't run into this too often anymore. And the reason why is because everything's just kind of set to auto. You have almost all devices out there, regardless of what they're capable of, well, they're backward compatible to the older technologies. And most of your network cards, regardless of what speed that they can handle, well, they're backward compatible to the slower speeds. And then, to go a step further, very often they are all auto-configurable, where they auto-configure based upon how things are connected on the other end. In other words, there's a lot of negotiation that takes place now, and the speeds and the duplex settings are all dynamically configured. Now, going down from there, here we have incorrect VLAN, and VLAN is virtual LAN, which is, we talked about earlier, where you can set up a virtual LAN, which is a way of segmenting your network into different virtual logical networks. Well, a device might be on the wrong VLAN. If they're plugged into a port on a switch, and the port on that switch has been configured to one VLAN, but it's supposed to be part of another VLAN, that can be a problem. Here's one for you. Incorrect IP address. Matter of fact, all four of these last ones, incorrect IP address, wrong gateway, or this could be default gateway, because that's what we're referring to, not the protocol translator gateway. We're talking about default gateway. So we have IP address, default gateway, DNS, meaning what DNS server are we pointing to, and subnet mask. They're all part of your basic TCP/IP configuration, and if any one of them is not set up correctly on a network device, and when I say a network device, usually in this case we're talking about computer. We could be talking about a router, but usually we're talking more about a computer. If you have the wrong IP address, something that's not part of the subnet you're supposed to be on, you're not going to communicate. If you have the wrong gateway, well, guess what? You might be able to communicate with other devices on your own network, on your own subnet, but you're not going to get off of that subnet or off of that network because you're not pointing to an appropriate router to get yourself there. Wrong DNS, if you're pointing to the wrong DNS server, you're not going to have name resolution working for you, because you're going to point to a DNS server that doesn't know, well, actually you may be pointing to no DNS server, or you could be pointing to the wrong DNS server that doesn't know how to service your needs. And then, of course, wrong subnet mask, because, of course, every IP address has to have a subnet mask. And if you don't have the appropriate subnet mask, well, then that IP address is effectively changed. Right? I mean, if you have the IP address of 192.168.10.200 with a subnet mask of 255.255.255.0, that's completely different than if you have the same IP address but a subnet mask of 255.255.0.0. So you want to make sure that that is correct. And I will tell you that if you are planning on taking certification exams, expect to see questions. And I'm not even talking just about the Network Plus exam. There's a number of different certification exams that I have taken, and these are some of my favorite questions. They'll just show you an IP configuration, and then they'll tell you a scenario, and they'll say, what's wrong? And you got to figure out, is it the wrong IP, wrong gateway, wrong DNS, wrong subnet mask? Those will be the four multiple choice answers you can choose from. Great. I love those because those seem to be so easy to pick out. For me, anyway. So, although those may be common test questions, guess what? Those are common real-life issues as well. When a user says they can't connect to something, if you are able to determine it's that user who's having the problem, very first thing I do is I do an ipconfig command to pull up their IP address, subnet mask default gateway, or possibly ipconfig/all to include the DNS server, and see if they're set up right before I go any further. Right? Talk about keep it simple, stupid. Hey, that's as simple as we get. How are you configured? Is it right? Yes? Okay, then it's something bigger. No, you're not configured right? Okay, solved your problem. Reconfigured you. All right, moving along. Issues to escalate. Well, it's not so much that these are specific issues that you need to escalate. Now, earlier I talked about, if you're not able to resolve something on your own, then you're going to want to escalate it to the appropriate party. Well, on the list of objectives for the CompTIA Network Plus exam, they have these 5 items listed as issues that should be identified but escalated. So I've listed them here in that manner, that these are issues to escalate. Although you may, depending on the environment you're in, be able to resolve these on your own. So what are these? Well, first of all, we have something called a switching loop. And this basically has to do with when you're on a switched network, when you're on a network using switches. If you end up with a scenario where a switch has multiple paths to get to the same destination, you may end up in what's called a switching loop, where basically the signal just keeps looping around. It doesn't really know where to go. Now, when we talked about switches, we talked about something called the spanning tree algorithm. Now, the spanning tree algorithm is supposed to help prevent switching loops, but it doesn't always work. And I can tell you firsthand, only about a month ago, here in my office, we accidentally ended up with a switching loop. It just kind of happened out of nowhere, because when I went through to troubleshoot the situation, what I found was that we had the switching loop, but I don't think anybody made a change. Meaning we had this loop for many, many months, and then all of a sudden it just stopped working. And we couldn't figure out why it wasn't working. And so, again, sometimes you scratch your head and you say, I don't really understand why, but what I was able to recognize is that one switch had 2 cables, both going to another switch. And you ended up with a loop just going round and round and round. And in fact, one of the switches just had its transmission signal light going nuts. And so basically it was almost like a denial of service attack on that switch. It was just being pounded so hard that switch just kind of crapped out on us and just wasn't servicing anybody. So that's a switching loop. A routing loop is sometimes created by the next problem, which is route problems. They're kind of related. A routing loop, to be specific, has to do with, well, just kind of like what it sounds like. It means that you have routers that are configured in a way that you end up sending a packet from one router to the next, to the next, to the next, and then back to the first. And you just got to keep going round and round. Meaning you never get to an actual destination. Well, that is created because of, well, route problems. In other words, if your routing tables on your routers are not configured properly, well, then you can end up with problems getting packets from point A to point Z because they don't know how to go through the various routers. And I will tell you, when it comes to route problems, I really cannot emphasize enough the importance of going back to the absolute basics of troubleshooting. And when I say the basics of troubleshooting, I'm talking about the very first thing I said in this video, which is this big picture process of knowing how things work. Knowing how everything is supposed to work, and then going through the process and seeing where there's a failure. And so when it comes to route problems, what I typically do is I will literally start at the source computer, we'll say. We'll call that computer A. And I will look at computer A's routing table and say, I have a packet destined for this IP address, which is computer Z. and I look at its routing table and say, where should I be sending that? And it will tell me I'm supposed to go to some router. And then I go to that router and I keep it really simple and look at that router's routing table and say, based upon this routing table, where would I send that packet? And then wherever it is I send it, I go to that router's routing table. And I just continue that process until I see exactly why the packet is not getting to computer Z. Or, believe it or not, sometimes you make it to computer Z. It's the return packet, the acknowledgement, doesn't ever make it back to computer A. So route problems is something that you really need to take a good hard look at. And I will say, this is an issue that very often does need to be escalated. And the reason why is because very often you can't go to every single router all on your own. So it may not be that you escalate it to somebody else. You may need to call somebody else in to participate with you. All right. Moving on from there, we have something called proxy ARP. Now, ARP, we learned earlier, is the Address Resolution Protocol, which has to do with IP addresses being resolved down to MAC addresses. And proxy ARP has to do with one device going through the ARP process or resolving that IP address to a MAC address, but to one that's not necessarily its own, thereby proxying for another device. Proxy ARP by itself is not necessarily an issue. It's that proxy ARP can create issues if you're not really careful in how it's set up. You can have devices that are acting as a proxy ARP but aren't actually capable of doing so, and then you end up with a big issue. And the last issue we have here is something called a broadcast storm. Now, a broadcast, we learned earlier, is a transmission where basically it's sent out by one and it's destined for everybody. It is a signal that is sent out for everybody. Well, guess what? When you send out a signal to everybody, have I said everybody enough times in the last minute? When you send that signal out, well, that's a lot of traffic you're creating, right? Because every single device on the network now has to acknowledge that signal. If there are too many of these broadcasts taking place, well, then that's what's called a broadcast storm. And the problem you can have is that you'll end up having the network just being amazingly slow because of all this broadcast traffic. Now, the last set of issues we're going to take a look at here are our wireless issues. And none of this should come as any great surprise because in the wireless video, we already talked about just about all of this. I mean, what are some of the issues we can have with wireless signals? Well, we can have interference with those wireless signals. If we are using encryption and the client and the wireless access point aren't agreeing or configured to use the same encryption, you can have a problem. Same thing with the channel and frequency. If the client and the wireless access point aren't configured consistently, then you got an issue. We have our ESSID mismatch, right? Sometimes you'll have somebody say, I don't get it. Why am I not connecting to, maybe the client believes they're connected. They're on a laptop. They got a wireless signal. They think they're on your network. They want to know why they can't get to certain servers. Well, because maybe they've actually connected to some other wireless signal, not the correct one. Now we have our standard mismatches, which is just plain and simple. Hey, maybe you have your wireless access point supporting 802.11g and you have your client set up to use 802.11b. Now again, this is not a typical issue these days because most devices end up being backward compatible, so they support their current level and all previous levels. And then also there's a lot of auto negotiation that takes place, but it is possible that you can manually configure it and end up with a mismatch. Distance. Well, just like we have attenuation with our cables, well, wireless signals can also only travel a certain distance. And if you are too far away from the wireless access point, you're not going to see the signal. Next we have bounce, and bounce is an issue that is, well, there's a couple different areas of this issue. One could just be the literal issue where you have a signal that is bouncing off different physical objects. So the signal's not actually going where you want it to, and maybe it can't even get to where you want it to. But there's also another aspect of wireless bouncing, which has a lot to do with a signal partially getting through an object. But the bottom line is just think of it as bouncing when it comes to wireless has to do with the signal bouncing off objects, because it will do that. And obviously some signals are going to be more susceptible, certain frequencies are more susceptible to this bounce than others. And then finally, and this really relates a lot to the distance issue that we were just talking about, well, incorrect antenna placement. If the antenna for your wireless access point is not placed properly, well, you're not going to get the wireless footprint that you're looking for. And therefore, you're going to end up with some wireless issues. So, now you should know how to effectively troubleshoot network problems. And here's the thing. I know we talked about some of our common connectivity issues, and hopefully you're now familiar with them all. But effectively troubleshooting network problems really has to do with the overall understanding of the process of troubleshooting. It is way more important than any specific knowledge that you can have. Okay, the process of troubleshooting is what's going to really set you apart from other IT professionals. So anyway, that's it. That's all we got for troubleshooting. I feel confident that you can go out there and fix some networks now. So I'm going to wrap things up here, and I'll see you in the next video.